Hello everyone, welcome to the Australian Informatics Olympiad 2022 editorial. First, why the first editorial we make is the 2022 one, not the others? This is because if you go to this website, you will have some AIO editorials written by AMT. But you will find that there's AIO 2021, AIO 2024, and AIO 2023 editorials, but they just don't have AIO 2022. So I don't know why. Well, anyway, I wanna fill this gap at first. So let's look at the overall difficulty now. For the problem 1 and problem 2, they are very easy, and the difficulty, I think they are same as the first two problems of the AdCoder beginning contest, which is pretty easy. And for the problem 3 and problem 4, they are a little bit harder, but they are same as the problem C of AdCoder beginner contest. And for the problem 5, they are not that easy, but their difficulty is corresponds to the problem D of AdCoder beginner contest. And for the problem 6, this is a very hard math problem, and the difficulty corresponds to the problem E or F of AdCoder beginner contest. Now let's look at the first problem, section 2. If you wanna see the statement of the problem, you can just open maybe a new tab or just pause here. This problem is very easy. What you need to do is just count how many votes each candidate has, and see which candidate has more votes than the others. If no such candidates exist, then it's a tie. The code is here. We have variables a, b, c, n, and a character variable ch. We do a for loop to count how many votes each candidate has, like this. And then we use if to see whether A has more votes than B and C, and whether B has more votes than A and C has more votes than B and A. And if no such candidates exist, then it's a tie. We just say out T like here. That's it. And for the second problem, level ground. You want to find out the largest rectangle. What we need to do is just greedily grab segments with the same height and use the biggest one as the answer. So like this, we grab this, grab this, grab this, and for here, they have the same height, so we just grab them all. And that's how we solve this problem. Just use greedy algorithm. And here's the code. Like here, we have variables n, num, length, height, answer. We just read in the height, and if the height is not same as the previous height, then it means we will have a new rectangle. Like they don't have the same height, so it's a new rectangle. And then we just update the answer here, and update the height, update the length. And no matter what, we just add 1 to the length. And remember to update the answer after the loop, because we will update the answer like after every time the height is not same as the previous one. But here, we need to do with the last rectangle. For the third problem, TSP. And again, if you want to see this problem statement, just pause here, open a new tab to watch this. For this problem, we noticed that we could always sell at least L tomatoes, but we may not be able to satisfy the condition of sell at most R tomatoes. Therefore, we use greedy algorithm to sell fewer tomatoes every day. Then it will be easier to satisfy the condition of sell at most R tomatoes. First use greedy algorithm. And here's the code. We have array L and R to store the data. Like here, we read in all the data. And then we use a for loop, and pre means how many tomatoes you sold yesterday. So the tomato you sell today is the at least value you need to sell, or what you sold yesterday. So here, if what you sell today is more than the number you need to sell at most, then you just say out no. Otherwise, if you finish all the days, you sell n days, and then you didn't quit your program, then you just say out yes, because you can satisfy all the conditions. That's it. Now for the fourth problem, beautiful buildings. If you want to modify the ice building to improve the ugliness, then we just change the height of the building to any value between the heights of the adjacent buildings. For example, if you want to change the second one, this building, if we change the height to here, then the ugliness doesn't change, right? And just if you change between this, the ugliness this contributes to, and finally it's like the first one minus the third one. So no matter what the height is, if it's between the first one and the third one, the ugliness doesn't change. But if you like do a very tall building, modify this like as tall as this, then the ugliness will be get higher, you know. And if you want to modify the third one, you just put this to the any height between the second one and the fourth one, then this will be good. And just know that we need to try to change the height of the first one and the last building to the height the building next to them, because like the remaining buildings both have two buildings adjacent to them, so you need to treat with like the first one and the last one. And this is the code for this problem. We use the array A to store the data, and like this, we first read in all the data and calculate the ugliness to the variable sum. And then we use the variable minus to see how much ugliness we can improve. And for this, we try to change the first building, and we try to change the last building as well. And we like choose the bigger one. And here we use the for loop from the second one to the second last one. And before means like before you change the height, it's like this. And after you change the height, this will be like the absolute value of the height adjacent building. And finally, we update the minus to choose the bigger one. And here it's like the origin ugliness minus how much we can improve. So that is. Now for the fifth question, composing pyramids. And again, you can just pause here to read the statement. And here's some sample input, sample output as well. And for this, deleting elements is difficult to consider. So instead of finding the minimum number of the key to remove, we try to find the longest composing pyramids. To find the longest one is like better than finding the minimum of the key you need to remove. For each key in the sequence, we use the DP idea to find the longest sequence that starts from that key, where each element is decreased by 1, both to right and to left. For example, in this sequence, the sequence starts from 4, and to the left is 3, 4, and to the right one is 4, 3, 2. And the final longest sequence is 3, 4, 3. Therefore, we need to use the shorter sequence to ensure that the sequence starts and ends at the same number. That is, though we can have 4, 3, and 2, but to the left one is 3, 4, which is shorter than this, and we just choose the shorter one. to make sure that it starts from 3 and ends at 3 as well. And to do this, let's say the array A stores the origin data, and B represents the length of the sequence starting from I. So here it is, like the length of the sequence starts from I. It will be like put itself to the end of the sequence that starts from the number -1, and the length will pass 1 because you put itself to the end. And here, this is the code. Like here we use 4 arrays, and this we first read the origin data here, and just do what I did. And for C, we just store like the length of every place to the left, because we need to do to the right as well. So we need to store this here. And then we use a for loop from n to 1. And we do the same thing, but here we need to record the answer. And again, we update the answer to try to make this as big as possible. And here, like, we choose the minimum, which is the shorter sequence, and times 2 minus 1. And when you see out the answer, you need to see out n minus answer, because the answer here is like the longest sequence, the longest length. But the problem is asking you the minimum key you need to delete. So here you need to like minus this. And finally, to the last question, the sixth problem, which is space shift shuffle. This is a very hard math problem, so there will be lots of math formula. The main idea is to define xi as the total number of people moving to the left in the ice cabin. If it's negative, it means the number of people coming from the left cabin. Because after we know all the x, we'll know the exact way to transform them, rather than like, cause each cabin there will be people moving to it from left and from right, and people moving out from it from to the left and to the right. It's like kind of mess. But if you have x, then you know the exact way to transform them, so it will be much clearer. And now we have the following relation. It's like this: a1 minus x1 plus x2 equals b1. What does this mean? It means like the original number you have here minus the people moving to the left plus the people moving to here from the right cabin. And it's same as like this and here, because this is a circle, so we have an minus xn plus x1 equals bn, because this is a circle. And then we just rearrange this to here like this, just rearrange from this, and then substituting the above formula into the current formula, like, because here we have x2 and we just substitute this x2 to here, and like we have xn here and just substitute here this xn to here, and we will have this thing: x2 equals b1 minus a1 plus x1, which is same as this. x3 equals b2 plus b1 minus x2 minus a2 minus a1 and plus x1, and then we'll continue just like this. And finally, we can see like all the other things can be represented by x1 and the number we already know, like x1, 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 and something we already know because we know a and b, right? So what we need to do is just to determine what value is x1. So it's like here. We need to find the proper x1 to minimize the answer. And the answer will be the absolute value of x1 plus x2 plus x3 plus xn. Because like x1, x is the number of people transforming. And according to the formula we made, this will be equal to x1 minus c1 plus x1 minus c2 absolute value, and so on. And ci equals ai minus 1, ai minus 2, and so on, minus bi minus 1, minus bi minus 2, and so on. Just like this. Just copy the formula in the previous page. And finally, x1 would be the median number of C by just using a common median trick. Here's the proof. Like here, if we have 6 C's, like C1, C2, C3, C4, C5, C6, they lie on a number line, and you wanna just determine a place that fits x1. And the blue place, like here, the x1 could be every place here. And if we put x1 here, the final answer will be C4 minus C3, C5 minus C2, C6 minus C1, right? But if you put x1 to the other place other than the blue place, for example, you put x1 here, then the final answer will be C5 minus C2, C6 minus C1 as well. But if you get C3 minus the x1 and C4 minus the x1, which is bigger than C3 minus C3, C4 minus C3, obviously. So that's why we need to put this to the median. The code is very simple. It's like this. We have 3 arrays, and we first read in all the data, and then we do the C array, which is like what we did before. C is like A plus A plus and minus B minus you know, and then we sort this, and in order to find the median, and each time we just do the absolute value of this, and this will AC. But anyway, you need to remember to use long, otherwise you will get some wrong answer. So that's all. Thank you for watching this. If you have any questions, feel free to ask us. And if you want to watch more or write tutorials, just subscribe to us. Thank you.